Now do know that there's a confidence interval that you can compute if you are asked to do a confidence interval for a population mean when sigma is actually known. However, going forward, since we have that t critical value when sigma is unknown, rarely will you ever be asked to actually use this confidence interval. I do not think you would expect to see this on a free response. You might see one question as a multiple choice asking you about this. If you were to actually compute a confidence interval when the sigma is known, then you would use x bar, or the sample mean, as your point estimate, and you're going to do plus or minus. You're going to find your critical value using the z-score, or the normal distribution, and then your standard error is just sigma over the square root of n. Keep in mind you can also find these conditions that you would check for this particular confidence interval in the handout that I gave you, along with what calculator screens you would use to compute that in the actual confidence interval itself. Odds are you will never be asked to fully compute this confidence interval. However, you may see a multiple choice question that relates to if you know the sigma or not, in which confidence interval you would actually compute. In 8.3d, let's determine the sample size required to obtain a confidence interval for a population with a specific margin of error. And we're going to do it this time when we do know the standard deviation of the sample size. Therefore, the margin of error we're going to focus on is the one where we use sigma over the square root of n. We've seen examples like this before, but let's do one specific one related to an actual z-interval when sigma is known. Here, administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate the mu at a 90% confidence with a margin of error of at most 30 minutes. A pilot study indicates that the standard deviation of time spent on homework per week is about 154 minutes. How many students need to be surveyed to estimate the mean number of minutes spent on homework at a 90% confidence with a margin of error of at most 30 minutes? Keeping in mind this is the formula for the margin of error, basically what's added and subtracted to create our confidence interval. We can fill in the necessary information. To be 90% confident, we're going to have to find the z-star, or the critical value, using our normal distribution for 95% of the curve. So let's do an inverse norm at 95% with a 0 and 1 to figure out the z-value for that. When you do, you're going to find that this value is 1.645. So we have z-star. Let's just plug in the standard deviation. We don't know the sample size, but we know the margin of error has to be less than or equal to 30. Now, the approach to solving this, what they've done in the book, we've seen this before. They're going to just rewrite this formula and do their solving so they can compute the n. When we do that, the n value is going to be has to be greater than or equal to 71.3. So in this case, we can say you have to survey at least 72 students. Now, let's talk about some details again if you're struggling with how to actually solve this algebraically. Now, mathematically, what I would do is divide this side by the 1.645 so it comes over here. So I'm just going to show that I'm dividing it, and I'm actually going to remove it here. Now, I want to end up getting rid of the square root here. So what I'm going to do is come on in and actually square this entire value here, which I will square this, and then what happens when we do that is the square root goes away. And we could actually write the equation so it looks like in this format. Now I can just cross multiply. I can bring this n up over here. I can bring the 30 squared down, and then I'm going to bring this guy up. And when we do that, what's going to happen is we will actually end up getting this same equation here that they have. So when I rewrite it, it's going to look like 154 squared times 1.645 squared over the 30 squared is equal to n. Again, this is the same thing that they have. So we're going to get the answer as being at least 72 people.